So we have Divya, who is a senior technical evangelist at Suse, and Saiyam, who is the director of technical evangelism at Civo, and they'll be talking about nuts and bolts of WASM. So handing over the dais to them. Oh yes, they are the speakers. They need a round, organizers. They need a huge round of applause.
So hello everyone. Hope you are enjoying the conference so far and the talk so far. So in this particular session, we'll be talking about WebAssembly, and nuts and bolts of the component model. So starting off, let's try to understand WebAssembly from very beginning, like what it was originally defined as. So you have, WebAssembly defined a portable, size and load time, efficient format and execution model, specifically designed to serve as a compilation target for web. So basically in web browser, you want to run other than JavaScript. So how you do that? Because there are languages who have, stronger aspects in certain areas that would really help in the performance and the isolation stuff, but also you want to run it in a secure way. So WebAssembly is basically the compilation target. So you compile your code, whatever you have written, into the WebAssembly module .wasm file, which is there, and then you will be able to run that in an isolated environment because WebAssembly's properties are like that, like the smaller footprint and small binary size and running very securely inside the browser. So this made a lot of great improvements, and we'll talk about two very big use cases as well. But also you can see in the down, I don't know how much visible it is. So you have Java applets, VB script, Adobe Flash. So this kind of effort has been done before in certain aspects, in certain language oriented areas, which are not the universal format. But this one, WebAssembly, is different because it has learned from previous, you can call it as mistakes, or you can call it from experiences of other languages like JVM, .NET, and all those. And it is W3C standard, certified. So basically, HTML, CSS, JavaScript are inside the W3C, and so is WebAssembly. So that itself gives a huge credibility towards this particular language format model because of its specification that people are all the people from various big organizations are working together to make this happen, to standardize different things so that we are moving in the right direction. Moving on, WebAssembly success in browser. How many of you are aware of Adobe Photoshop and Figma? So these are very heavy applications, and running those inside the browser have only been made possible using WebAssembly. And they are one of the biggest success stories of WebAssembly. But not only these, like certain parts of aspects of BBC runs on WebAssembly. Then you have many other aspects of in the CNCF ecosystem. There are various blogs talking about that as well that have contributed towards success. So that raises up the question that is WebAssembly only for the browsers? No. Because of the important features of instant startup time, small binaries, multi-platform isolation and security, WebAssembly proves to be the perfect candidate for the server side as well, especially in two main ecosystems that Matt also touched on, in the serverless ecosystem and the next gen of the, in the virtual machine, containers, and WebAssembly. So that next module in that particular sequence, if we talk about. So that is very important because servers were heavy. Then you have virtual machines that virtualizes the server. Then you have containers that virtualizes the OS. Then you have the WebAssembly modules that only is the executable part of your code. It doesn't have any knowledge about the operating system that it is running on. It doesn't know where it is running. It is platform independent. Even you can argue some stuff between containers and WebAssembly. I'm not sure whether I have included that particular slide. Can you go next? Yeah. So so now WebAssembly is on the server side, and there are a couple of things that makes it possible to run on the server side. So you might have heard from Matt's talk itself. One is WASI, which is WebAssembly System Interface. So since WebAssembly module is unaware of the operating system that is there, so it talks to the WebAssembly layer and the runtime, that it comes in the runtime. So you talk to the runtime, and that itself gives the call to the local file system if you want to access any file, or if you want to do any system host operating host related function calls. So you will be able to do that using Vazi, because that is what only that makes WebAssembly to run properly on the server side. And this is where the famous quote also came in from Solomon Hykes back in 2019 timeframe, that if Wasm and Vazi existed back in 2008, then he wouldn't have created Docker. Coming from Docker creator, that itself means a huge thing. But he also said another thing in the subsequent message, that he foresees a future where Docker containers will respect WebAssembly a lot, and they will be running side by side. And that's what actually happened last year. So Docker invested heavily in WebAssembly, and as of today, you can use your same developer tooling with same Docker build, buildx, Docker run, same commands to build and run your WebAssembly workloads as well. So that shows the commitment of the companies, big companies, proving it right. Also, the thought leaders, their statements are proving to be right. So that is why everybody is excited about it, changing the way of how you write the applications. Certain aspects, especially there is one more thing about which the community is pretty excited about, that is the component model. So let's say you have you have a Python, like you wrote a Python program that I really want to use. So how do I use that? How do I make my application truly polyglot? How do I write my Rust code and I import, just using a simple import statement, and import your Python library that does a very good job in whatever it does. And also I don't have to reinvent the wheel. So how do I do that is using the component model, which Divya is going to explain now.
Thank you. Thank you for that wonderful, precursor to the component model. Now, before we dive into the component model, I want to, take a quick survey from the audience here. How many of y'all have ever had the misfortune of having leftovers after, you order takeaway from outside at your home? Anyone? Okay. Wow. Do none of y'all order from outside, or are all of y'all, like really good at ordering? Like, please teach me how to do that. But in case this analogy doesn't work, I'm still happy with it. But when you order takeaway, or you cook something in excess, right? It's a typical thing in Indian homes to actually reuse and recycle whatever is there in the fridge. My mom does that ever so often now that, everything is like ready-made at home. And that's probably what I think, most of y'all would have done if y'all had leftovers after food. But let's think about the other options that were presented, right? Like, if you had leftovers in your fridge, would you whip up something brand new from scratch? You wouldn't. Why would you? Because there's already food that should not be wasted. So you'd probably consider reheating the leftovers, or if you're slightly unhinged, you'll just take the food off the fridge and eat it. Like, if it was pizza, I think I would just do that. So there are like 3-4 options available. One, you cook something from scratch, or you order just another takeaway. You reheat the food, or you convert it into something new. Now, you might ask me, hey, how did you just go into, Khana Khazana or MasterChef India here when we're talking about WebAssembly? But bear with me. Component model of WebAssembly, if you just listen to what Saiyam said, has a close resemblance with what we do when we have leftovers, or when we have something that we can reuse, recycle, and make it into something new. Component model takes existing code, converts it into a component, and essentially allows you to reuse it with the help of a Componentizer API in your existing code. Now, I have said componentizer, component model like a bunch of times by right now. So, what is a component? Why is she talking about the component model and not telling us what a component is? So, have you all, seen what a WebAssembly module looks like? If not, a WebAssembly module is essentially a bunch of numbers, because it's a binary instruction format and it is the output of a compiler. So because it's the output of a compiler, it's just a bunch of zeros, ones, twos, whatever, numbers basically. So Bailey Hayes, in her talk in the Cloud Native WebAssembly Day, called the WebAssembly module, which is the fundamental unit of a WebAssembly program, as a bunch of numbers parading in a trench coat. Now, I would call the component as a bunch of modules that are parading in a trench coat. And the best part is that these modules can actually talk to one another. Despite all the, problems, not problems, but it's an inherent design and it is an inherent, feature of WebAssembly that, it's sandboxed and it's secure. So despite that, how are, these modules able to talk to each other? And that's where the concept of a world comes in. The world, I wouldn't call it a feature, but the definition of a world within the component model essentially is literally the definition of the inputs and exports of that component that you are writing in a format known as WIT. And this essentially represents the execution environment of the component that you just created. Next slide, please. This can actually look like this. Basically, if you have a world defined here, it can actually look like the type. I don't know if you're able to see here. It can actually look like or can be analogized to this particular screenshot here. And it's like defining a type in normal programming. Next slide, please. And all these components, after you create them, what do you do with them? You can't just leave them in space and run away. And, you can't just store it in your local computer and expect people to find them. So for that purpose, we have the component registry, which is a federated namespace of WASM components. Now, WORG, which is the WebAssembly registry, is one of the projects, and it's under the Bytecode Alliance. And the component registry implements package transparency to sort of enhance the security of the components that are stored within the registry. And how does it do that? The package transparency bit is by using a cryptographic verifiable log. I always get that wrong. Cryptographic verifiable log of anything and everything that happens to that particular component in the registry. Next slide, please. So you've created your component. You've stored it in a registry. Now what? Like, I have written a component. What do I do with it? Like, it's just lying there. So you can independently execute it using a WebAssembly runtime. Componentizer is what you would use to essentially reuse the code, like I said in my food analogy, which did not land well, I admit it. You would use a componentizer to essentially transform your source code into a component. And last but not the least, a composer does the Indian mother's, or rather my mother's equivalent of, reusing and modifying the code and, making it into, modifying one component and making it into another one. So Composer basically does that. Now, what are benefits of this? One of the benefits of this is what Saiyam said before, platform agnosticity. And obviously, with platform agnosticity, another thing that WebAssembly also brings is a greater number of languages. And this is an incomplete list. It's not like the, holy grail right now. It's not that these are the only ones, but more and more languages can actually be brought in to, write programming. And that's essentially what we want, right? Write once, run anywhere. That's what we started off with. When we thought of, programming and development, we want to write in the programming languages that we are comfortable in. We don't want to sort of learn Go, learn the next big thing that comes up, after Go. I don't know what that is, but whatever it is, we don't want to learn a new language every single time it comes up. We want to be able to write in our own language. And we want to be able to run it on the systems that we want to run it in. We don't want to customize and, do all the frills and fancies every single time we write code. And that's essentially what WebAssembly offers you. And that's what, with the component model, the vision of, WebAssembly is. And we're bang on time with the presentation, which I thought we would not achieve. So thank you so much, and I hope you have a fantastic conference after this.
Yeah, thank you so much. Just before ending, if you want to see, some of the demos and stuff like that. So Fermion is one of the sponsors over here. They are very deep into WebAssembly ecosystem, so you can ask them anything in terms of that. And then those who have registered for the WebAssembly workshop, you already have that thing hands-on coming in. And yeah, if I and Divya get time today, we would love to show you demo if we are hanging around, which is difficult, but we'll try. Thank you so much, and enjoy the conference.
Yeah. Thank you so much. Bye, guys. And girls.
Thank you guys. Your passion on the subject matter was quite evident, and I'm sure everybody would take away something from this talk.